All right. Hello, everyone. My name is Elle Wernette, and I am going to be talking to you all about sleep today. So the title of my presentation is What's the Buzz About Sleep? So without further ado, we're going to jump right into it. And just so you all know, we will have time for questions at the end of the talk. So get familiar with the Q&A function in the Zoom webinar to submit your questions during the talk at any point that you have them, and then we'll get to them all at the end. So I first want to talk a little bit about becoming a sleep researcher. So I'm currently a fourth year student in my PhD program. And my program is actually in the psychology department in the cognition and cognitive neuroscience program. And I specifically work for Dr. Kimberly Fenn in her sleep and learning lab. So here is a slightly outdated picture of us pretending to be asleep. And these are all of our lab members, although it's an outdated picture. And I also got my Bachelor of Arts in Psychology from MSU. So I am a Spartan at heart, and go green to any of you MSU fans out there. So first, let's talk about what sleep is. So it turns out that sleep is actually pretty difficult to define. But scientists thus far have come up with the current definition for sleep, which is a periodic, natural, and reversible loss of consciousness, which I think sums it up pretty nicely. And although some people might say, well, most people are not moving when they sleep, it's actually not a characteristic that's true of all animals. So it turns out that some animals can still move while they sleep. So migratory birds, for example, some, such as the frigate bird up here, can actually sleep while flying. So if you look up in the sky and see one of these birds, it's actually a little difficult to tell whether or not they're awake or asleep. Slightly different, but dolphins actually sleep with one half of their brain at a time. So they can actually continue doing some of their waking activities like swimming, even though half of their brain is asleep and getting its rest. So being immobile during sleep isn't necessarily a requirement of sleep. So that's why the definition has been reduced to a periodic, natural, and reversible loss of consciousness. Another question you might ask is, okay, so what animals sleep? And it turns out that a lot of animals, almost all animals sleep. So there's evidence so far that all mammals sleep, that birds sleep, reptiles sleep, some fish sleep. So for example, the zebrafish is an animal that's used a lot in sleep research. And fruit flies even sleep. So there's research on a bunch of flies and figuring out when they sleep and for how long they sleep, little tiny fruit flies. And then one thing that we do know is that even though all these different animals sleep, they actually tend to sleep at different times of the 24-hour day. So for example, there are diurnal animals, and actually these words describe when these animals are active, so it's a little bit confusing. But diurnal animals are animals that are active during the day, like us, and sleep at night. Nocturnal animals are animals that are active during the night, but then sleep during the day. So animals like rats are nocturnal. And then there's also, crepuscular animals. And these are animals that are active during daylight, or active during twilight hours, pardon me. So things like mosquitoes, bats, things that come out during those hours when the sun is just set or when it's just risen or just before it's risen. Some of these animals are actually active during those times and then sleep during other parts of the day. So turning back to humans, I think something that's really interesting to talk about is how we are actually able to measure sleep in humans. And there's a few different ways that sleep scientists do this. So the first is through sleep diaries. So sleep diaries are a really easy way to ask participants in a study or just people in general about their sleep habits for the past few days. So we use this in a few of our studies, and what we do is we give participants forms with all these different questions like the ones that you see here. And then we ask participants to fill them out, and then we calculate based on their own answers to these questions how long participants slept for, let's say, 5 nights ago or 4 nights ago, based on their answers to these questions for that night. There's actually a few problems with this. A lot of people don't have a really good idea of exactly how much sleep they've gotten. So another good way to measure sleep is with actigraphy. And actigraphy is actually a way of measuring activity and rest cycles. So things like Fitbits do this, Apple Watches do this. So here's an example over here of some Fitbit data from a person who is sleeping. And what this actually does is give scientists an objective measure of sleep during a given period of time. So we also use these in our lab, and they're pretty reliable, but they don't actually tell us super detailed information about sleep. They can mostly tell us when a person was asleep or awake. So the last measure that we can use is polysomnography. But first, I wanted to also make the point that actigraphy is a really common way to measure sleep in babies too. So by putting like a little tiny monitor, something that kind of looks like a Fitbit or Apple Watch on their leg or arm, you can measure when babies are asleep versus awake and get sleep data on them. So it's a really safe and easy way to use. But polysomnography, the other method that I just mentioned, or PSG, is actually the best way to measure sleep for sleep scientists because it's really objective, it gives really reliable data, and it also allows us to look at really detailed information about sleep. So first, what is PSG? It sounds like just a really confusing word, but if you break it down into its Latin roots, polysomnography, it starts to make a little bit more sense. And what you actually see is that poly meaning multiple, somno meaning sleep, and then graphy meaning writings or recordings put together just really means that we're taking multiple sleep recordings of an individual to help measure their sleep, right? So here is a list of all the different measures that we actually include when we do polysomnography on our participants. So we do this in our lab also, and a lot of other doctors and sleep researchers use this as well. But we can measure brain activity using EEG. We can measure eye movement, muscle movement, heart rate, things like O2 and your pulse. So we have all these different measures. So participants end up being hooked up to all these different wires. And then we also use breathing belts to measure breathing rhythms. And then another funny thing that we're able to use is actually a snore microphone. So we attach a little tiny microphone to people's necks right about here, and it picks up the vibrations when people snore. So we have recordings of those, which is something a lot of people find interesting. And actually the benefit of using this method is that this allows us to study sleep. So we can look at really detailed information about sleep and its purpose. And then it also helps sleep scientists and doctors diagnose sleep disorders. So this is a really important benefit of this method. I mean, you might ask, well, it looks really difficult to sleep on all that technology. Our participants actually don't have too much trouble sleeping in our lab with all the wires on, although it doesn't look super comfortable. But you're actually free to move around and do all this different stuff with it on. So it's not as bad as you might think. So I mentioned that we get really detailed information from polysomnography, and what we actually can see from this technology is the 4 different stages of sleep that we've now come to know. The first stage is stage 1 sleep, and this is just really light transitional sleep that you might slip into when you're falling asleep or in and out of different stages. Stage 2 sleep makes about 50% of the time that you're asleep, so it's really the bulk of the sleep that you're getting in a night or in a nap. And something that's really unique about this type of sleep is that it's made up of certain waveforms in the EEG pattern that we get from polysomnography. So over here are all these waveforms that you're looking at. These are all different recordings from the EEG leads that we put on participants when they have all the polysomnography stuff on. So this is how we can tell the difference between these stages of sleep, is by looking at these different waveforms. And stage 2 is made up of these sleep spindles that you can see here and K complexes. So these really 2 distinct waveforms. Stage 3 sleep is also known as slow wave sleep, and it's the deepest and most restorative stage of sleep. And it's also really beneficial for memory. So it actually actively strengthens memory for information that you learned during the day. And as you can see, based on this picture down here of this delta sleep, the slow wave sleep, it's really distinct from all the different stages. And it has these really, really huge waves that are pretty spread out compared to all the different waveforms. So this is really the best sleep that you're getting and what you crave when you have a really long day. And then finally, what you've probably heard of the most is rapid eye movement sleep. And this is sleep that has been also called paradoxical sleep, because your brain is really active. So as you can see, this pattern here doesn't look too different from the pattern when a person is awake up at the top. But your body's actually paralyzed during this sleep so that you're safe and you can't act out your dreams. So everything, all your big appendages are paralyzed. And this is when you have the bulk of your emotional and vivid dreams. So you actually dream in all different stages of sleep, but these are these really emotional, vivid dreams that you have in this stage. And REM sleep is also known to help strengthen memory, particularly for actions and motor skills. So a really important question from here is, how much sleep do you need? And it turns out that sleep and need for sleep changes throughout the lifetime. So newborns need the most sleep, anywhere between 12 and 14 hours, as you can see over here on this graph, or over here, 12 to 16 hours, it's listed as for 4 to 12 months. So babies, newborns, all these really young kids actually need a lot more sleep than adults. And it starts to get less and less as the individual grows older. So school-age children still need between 10 to 11 hours of sleep. Teenagers need about 8.5 to 9.25 hours of sleep. And adults need around 7 to 9 hours of sleep. And a lot of people might say, well, I seem to do pretty fine and I get less than 7 hours of sleep. But it turns out that about a third of the population is not getting enough sleep. So it's really important, as you'll see in the next few slides, to make sure that you're getting the sleep that you need and really capitalizing on it. A really good way to do this is to schedule sleep like you would schedule something else that's important in your life. Make a really strong effort to get the sleep that you need. So now a little bit about what happens if you don't sleep. The most striking thing, it's really rare, but it's obviously the most consequential thing that can happen if you don't get sleep, is unfortunately death. So if you sleep deprive rats in the lab, they'll actually die in about less than 1 month. And there's also a really, really rare genetic disease in humans that have showed us that death can also result from not getting sleep. So this disease, called fatal familial insomnia, or FFI for short, actually results in super severe insomnia where people really can't get any sleep. And once symptoms for this disease hit their onset point, people typically die within 1.5 years, so 1.5 years, which is pretty short prognosis. But as you can see here in this graph, on the top is a normal, healthy brain, and on the bottom is a brain of someone with fatal familial insomnia. And what you can see here is that there's a lot of reduced activity in the frontal lobe and in the middle of the brain compared to this other participant, showing that there's really strong effects on the brain of this disease, in addition to, ultimately leading to death. Also, an important thing to note is that night shift work, so working at the night during the night as a third shift worker, has been labeled as a probable carcinogen. So it's really important that you get sleep and that you get it at the time that you need it, as often as you can manage. Although this obviously isn't possible for everyone, it's just important to note and to be aware of the effects that not getting enough sleep can have, and make sure that you're making up for that in some way, and really prioritizing your sleep. So what else happens when we don't get enough sleep? So another thing that happens is that we lose cognitive functioning ability. So this is things like reduced attention, which can be a really big problem when you're driving. So there's a lot of studies on sleep loss in driving showing that there's a lot higher incidence of swerving over the lanes and changing your speed. So reducing attention is a really big deficit that occurs when you don't get enough sleep. Not getting enough sleep can also impair memory. And it can also affect other cognitive functions of the brain, like being able to complete complex tasks, for example. There's also the accumulation of sleep debt. So the more and more that you don't get sleep, this need for sleep actually builds up over time, ultimately forcing you to get sleep or to, have really severe reactions to not sleeping. And we know this from people like Tony Wright. So Tony Wright was a man who stayed awake for 264 hours to break a world record. So that's about 11 days. In 2007 is when he did this. And what we learned from him, so he kept a diary with him when he did all this extreme stuff. At one point, as you can see here, he had to even put toothpicks in his eyelids to keep them open. But what we learned from him is that as time adds on during this period of sleep deprivation, more and more of this cognitive functioning is lost. So by the last few days of Tony Wright staying awake, he couldn't even write in his diary anymore to record how he was feeling, because he couldn't complete that task. He didn't feel that that was possible. And he even hallucinated and all this crazy stuff. So through his records and through other people like this who have really done some extreme things with sleep, we've learned all the really nasty consequences of not getting enough sleep and how impaired you can really become. So another thing that can happen if you don't get enough sleep is that you can suffer a lot of health consequences as a result. So there's higher risk for obesity in people who don't get enough sleep, higher risk for cardiovascular events, and then there's increased markers of inflammation in the body as well during sleep loss. So normally sleep helps adjust all of these functions in the body and keep them working normally and in a healthy way. But what we actually see is that there are a lot of problems with these functions, particularly with the heart and having increased likelihood for cardiovascular events and obesity and type 2 diabetes in people who don't get enough sleep. So it really is something to take seriously in terms of your health. So it's a PSA to get better sleep. I know that I have prioritized it since learning all this stuff. So an important question now to ask is, okay, how can I improve my sleep now that I have told you all of this stuff about how bad it can be to not get enough sleep? And what we've seen is that a lot of people, so over 3.1 million Americans in the year of 2012 were reported as having taken melatonin supplements to help them sleep. And this is based on a study by the NIH, or the National Institute of Health. And if you just do a quick Google search, you can see that there is a lot of melatonin products and sleep aid products on the market. So this first picture here on the left side of the screen is just a quick Amazon search. But then I also went into my local pharmacy and took this picture to the right of all the different sleep aid products that are available, most of which were melatonin. And Americans spend about $408 million on melatonin products in a year. And this is based on data in 2017. So in 2017, this is how much money we spent on melatonin products alone. So there really is a market here. So an important question would be, what is melatonin and is it good for sleep? So melatonin is a hormone that's actually produced by the body. So you naturally produce this every single night. Your brain produces this because its production in the body is stimulated by darkness. So once it starts getting dark at night, your body starts producing this, and it's inhibited by light. So once the sun comes up in the morning, or you start turning on devices, things like that, your body stops producing melatonin. So what actually ends up happening is that melatonin production starts in the evening and continues throughout most of the night, and is then stopped in the morning once the sun rises again. And there's a lot of evidence and some research on taking melatonin supplements and what this can do for sleep. And what researchers have found is that melatonin can definitely be effective for relieving jet lag. So if you're doing cross time zone travel and you need to sleep at a time that your body isn't naturally wanting to sleep at based on the circadian rhythm or the 24-hour rhythm of your melatonin cycle, you can take melatonin supplements to help relieve that jet lag and get you regulated to the new time zone faster. Melatonin supplements have also been shown to improve sleep in some people with sleep disorders. So people with things like insomnia might benefit from taking melatonin because it might help them fall asleep faster by realigning that timing that you're scheduled to sleep based on your body's natural rhythm. So an important question here is, does melatonin actually help people who don't have these problems, or who aren't going through these circumstances? So people who aren't experiencing jet lag and people who might not have trouble sleeping. And we're actually doing some research on that in our lab right now. And preliminary results from our lab have shown that melatonin might actually benefit sleep in healthy young adults by making it so that they stay asleep more during the night as opposed to waking up multiple times. But it might also impair cognitive functioning the next morning. So we found evidence that after taking melatonin compared to not taking melatonin, there might be problems with attention and other complex cognitive functions in the morning. So these are just preliminary results. So we're continuing data collection on this study as soon as we can get back to in-person data collection. And we'll keep you all updated on those results. So last, I just want to talk about a few other tips for improving your sleep super quickly. So the first is to build a relaxing bedtime routine. So these are things that have been shown to improve sleep even when you can't go reach for melatonin or don't think that you're a candidate for taking melatonin. So building a relaxing bedtime routine might look like reading a book before bed, and then brushing your teeth, and then, doing all these other things in a specific order, all the same events during the time that you're getting ready for bed, so that your body starts to learn that this routine means that you're about to go to bed. So your body can start preparing itself for sleep at that point. The second tip is to create an ideal sleeping environment for yourself. And what this means is keeping your temperature cooler rather than warmer in your bedroom, turning off all of the lights, even the small little lights on devices. Those are enough to affect your sleep. So turning off all the lights that you can manage in your bedroom, eliminating external sounds, so making sure that there's not a lot of noise pollution going on around you. And if there is and it's unavoidable, maybe thinking about using earplugs or something like that to help you get better sleep. You should also work on reserving your bedroom for sleep. So not doing stressful things in the bedroom like work. I know that's harder to accomplish in this type of environment where most of us are working from home. But trying to keep your bedroom as a place for sleep and not TV, not devices, not things like that, so that your body knows that when it's in that place, your brain knows that it's time for sleep. The third tip is to keep your bedtime and wake time as regular as possible. So try not to change this up too much so that your body also stays on a really tight routine for that. The fourth tip is to reduce exposure to blue light before bed. So turning off your devices, making sure kids and adults aren't using their tablets before bed, and really just reducing any exposure to light from computer screens, TV screens, tablet screens, phone screens, all these different things. And if it's really not possible, maybe investing in some blue light filter glasses to help reduce that exposure that you might be getting that's unavoidable. The fifth tip is, I know this is kind of obvious, but to not drink caffeine late in the day. So I think a lot of people still do this anyhow, but just know that it takes a really long time for your body to get all of that caffeine out of your body. Even if you're drinking it early in the afternoon, it might still affect your sleep. And then 6 is to exercise. If you exercise, if you use up a lot of energy during the day, then you're going to have a higher need for sleep at night. So really using up your energy and getting good exercise and just, staying healthy in general are all really great ways to improve your sleep. So with that, I want to thank you all so much for joining in on this session on What's the Buzz About Sleep. If you have any questions at this point, I'm happy to answer them using the Q&A function in this webinar. And if you'd like to follow me or connect with me or ask questions later, you can keep in touch using my email, which is delgros1@msu.edu, or follow me on Twitter at LMD_Wernette. And that's my Twitter account. So I'm going to stop sharing now so that I can see if there's any questions in the Q&A. And it doesn't look like there are any quite yet. So if anyone has questions, please feel free to use the Q&A function to submit those questions and I'll answer them live here. Or like I mentioned earlier, if you would like to instead connect with me via email or Twitter, you can use this information here and submit questions at a later point as well. And I also have recorded this webinar today. So if you have people you want to share this with, I will be posting it on the website for this page under the virtual event. So I'm seeing some questions here. And the first question talks about, I'll read it out loud actually. The question is, I've seen apps that help you set off alarms to go off or set alarms to go off based on tracking sleep cycles. Can these really track your cycles based on movement? And that's a great question. So actigraphy, or the method of measuring sleep using activity cycles, so things like Fitbits, Apple Watches, apps on your phones that think that they're tracking movement and sound, are actually not quite accurate enough to get all of the stages of your sleep. So if you're in particular trying to avoid, being really groggy in the morning, what you might be trying to do is not wake up out of stage 3 sleep, or that really deep and restorative sleep, because you'll feel really groggy when you wake up out of that type of sleep. And these devices really aren't accurate enough to wake you up out of not that type of sleep. So they're not super accurate in that way. And really to do that, you'd need things like polysomnography, which really aren't accessible. But you can get a really good idea of your general routine for sleep time and wake time. And if you find that you naturally wake up, about 15 minutes later than you've set your alarm, then maybe you can make adjustments based on that and see if you're more comfortable. So you can still use these apps to your advantage, but they're really not going to deliver on all of their promises based on the detail that they really can get from your sleep, which isn't quite as much. So another question is about any suggestions on taking melatonin to get back to sleep. So my guess is that this is referring to when you wake up in the middle of the night, you realize you can't get back to sleep. Should you take melatonin at that point? And the answer is kind of variable because it depends on the type of melatonin you're taking. So if you're taking a fast releasing tab or a slow release tab, these are things that affect how long the melatonin is in your body. So for example, if you wake up at 3 a.m. and you take melatonin, there's no guarantee that that melatonin isn't going to still be in your body when you want to wake up the next morning. So you could have lingering effects of taking that in the middle of the night. But melatonin takes about 30 minutes, depending on the type of melatonin, but most melatonin peaks in your blood around 30 minutes after taking it. And because we know this kind of event, if you want to get back to sleep in the next 30 minutes and still relatively early in the night, it might help you fall asleep faster. But again, it depends on, if you are sleeping on inopportune times for your body, because it really seems that what melatonin does is help adjust your timing in your brain as opposed to actually getting you to sleep. And then another question is about how some older people might sleep for shorter amounts of time, like less than 7 hours, the recommended amount. And that's true. So as you get a little bit older, what we see is that there's a higher prevalence of advanced phase disorder, which is when your circadian rhythm naturally adjusts to be earlier. So you go to bed a lot earlier and you wake up a lot earlier, and you might get less sleep. That could be related to a few things. So I'm not necessarily sure that, you know, it's healthy at that point to still be getting not a lot of sleep. I mean, it could be related to other things. So if the person has other comorbid diseases or disorders, or has other health problems, that could be causing sleep issues as well that are limiting the amount of sleep that a person gets. But sleep changes throughout the lifetime, and it's different for every single individual. So just because, you know, someone you live with or a friend you have might sleep for, you know, 7 hours every night and feel fine the next day, you might not feel fine unless you get about 9 hours of sleep. So there is individual variation in the amount of time people need to sleep. But in general, most adults need more than 7 hours. Okay, so with that, I think we are out of time, but I want to thank you all so much for joining me today and for all of your questions. They were really, really great. And again, if you want to watch the session again or share it, it'll be on the page for this webinar for this session. And with that, have a great rest of the day, everyone. Thanks again.